let's finish this then. Yesterday we introduced something called the unit circle and the trig functions. And this book goes through the trig functions a couple of different ways. So this is one way. If you've seen it another way, we're going to get to that. Don't worry. We'll do that in the next section. But I want to make sure that we understand this really well. I think I emphasized this when I was talking about it in the lecture. These ideas right here on the special right triangles, really important. If you don't have that relationship memorized, if you don't remember that on a 45, 45, 90, the two legs are always the same, and to go from a leg to the hypotenuse, you times by radical 2. If you want to go from the hypotenuse to one of the legs, you divide by radical 2. And on a 30, 60, 90, everything can be figured out once you've got the short leg. So I say everything goes through the short leg. So if you know what the short leg is, the hypotenuse is really easy. You just double it. So if this is x, times it by 2, you get 2x. To go from the hypotenuse to the short leg, you divide by 2. And then to go from the short leg to the long leg, you times by radical 3. And if you're going from the long leg to the short leg, you do the exact opposite. You do the inverse. You divide by radical 3. Some people have a hard time remembering which is which. Gosh, is this a radical 3 that I multiply by here, or a radical 2, or where is that? There's only a radical 2 and a radical 3. There are no other radicals in there. And the way I like to remember it is the only one that has a 3 in its name, like 30, 60, 90, is the one with the radical 3. Okay? So you're never going to put a radical 3 on a 45, 45, 90 because there's no 3 in the name of that special right triangle. So I would make sure that you have that relationship memorized. That often comes up on an ACT or something like that, or some sort of standardized test. And then I would memorize them this way. I'd memorize these numbers also. So I'd know radical 2 over 2, radical 2 over 2, and 1. And know that the hypotenuse being 1 on a 30, 60, 90 makes this exactly 1/2. So this is 1, this is half of that. And then we times that 1/2 by radical 3, we get radical 3 over 2. These are really good ideas to have memorized. Okay? And then we talked about the unit circle being a circle with a radius of 1 centered at the origin. And then we went through and we marked off all the angles and radians. And again, something that would be very good to have memorized. You do need to get this memorized. And we went through and we marked each one of these points on the unit circle, starting at 0 and going by pi 6 and pi 4ths. So we get 30, 45, 60, 90, 120, 130, 135, 150, 180, and so forth, all the way around the circle in radians. And we know what the measurements are for each one of those points, what the coordinates are. Okay? This is something that you'd want to have memorized. Okay? I'd be happy to give you a nice copy of what this looks like, and I'll probably do that in the next section or the one after that. But this is something that you should get memorized. If you've got it memorized now, it's going to make what comes later on a lot easier, and it's going to make, when you take Math 1060, it's going to really make that a breeze. Okay? All right. So we went through and we talked about the definitions of the trig functions. We said sine of an angle is y over r, cosine of an angle is x over r, and tangent of an angle is y over x. Whatever the y coordinate is over the x coordinate, y coordinate over the radius. And we said on the unit circle, which is what this section is about, because the radius is always 1, that would be a 1, and that would be a 1. So that means the sine of the angle is just the y coordinate, and the cosine of the angle is just the x coordinate. And then we went through and we did a whole bunch of problems. We did a bunch of different examples. We did positive angles. We did negative angles. We did these ones here that repeat every 2 pi units. So if I start right here and go around the circle once to get to 2 pi, I get the exact same answer. And we called that the period of those functions. Okay? And that's where we left off. We're going to pick up right here. We've got this last page to cover, and then we'll be done with 4.2. It'll be officially assigned. Hopefully I'll have some time to work on it today and ask questions. By the way, I appreciate those of you that got my email yesterday and went ahead and filled out that quick little survey. I appreciate those responses. That's really good to know. Okay? So, we're going to talk about the domain, the range, and the period for each one of these functions. And when we say domain and range, usually we're talking x's and y's. Okay? So don't get confused here because we've got x's, y's, and t's floating around in these problems. We want to make sure we keep this straight. So let's talk about domain in terms of what we plug in that look right. So remember, the domain is what you plug into a function. Normally we plug in x's and get out y's. That's why the domain is normally an x. And the range is what we get out. So again, normally we plug in x's and get out y's. That's normally why we talk about the domain being the x's and the range being the y's. Okay? That's not what we're doing here. Let's take a look at each one of these. For this trig function, what we're doing is we're plugging in that angle, and we're getting out this ratio. Same thing here. We're plugging in that angle, and we're getting out this ratio. So the domain is what we plug in. So those are angles that we can plug in there. And the ratio in this case, the range in this case is the ratio. It's the y coordinate that we get out. So try and keep those straight. We're not talking x's and y's. We're talking about what are we plugging in and what are we getting out. Okay? So the domain on this is what angles can we plug into the sine function. Well, we saw yesterday, gosh, you can plug in 0. You can plug in 30 degrees or pi 6. You can plug in 45 degrees or pi 4s. You can plug in pi. You can plug in 2 pi. In fact, you can plug in negative angles. And you can keep going around the circle as many times as you want in any direction you want, right? So what type of angles can you plug in? Are there any restrictions on the domain? No restrictions at all. How do we normally say that? Yep. All reals are, we'd say, negative infinity to infinity. Okay? In other words, what we mean is any angle we want. Okay? You can plug in any angle you want into the sine function. Now, because what we get out is the ratio, the y coordinate, okay? So we're going to get out a y coordinate of 0 if we start right here. We're going to get out a y coordinate of radical 2 over 2 if we go to 45 degrees. We're going to get out a y coordinate of, what would the y coordinate be right here at the top? 1. And what about over here? 0.5-ish or something like that. Then 0. What type of y coordinates do we get out down here? We get negative y coordinates. What's the biggest negative y coordinate that we get? Negative 1. Okay? And then we start going back up to 0. So the y coordinates start out at 0. They go up to 1, back down to 0, down to negative 1, and back to 0. And if I keep going around the circle in either direction, am I ever going to get a ratio, a y coordinate out that's bigger than 1? What about less than negative 1? Never. Okay? So here's the range, negative 1 to 1. And how often do these repeat? How long does it take this cycle to repeat itself? 360 degrees, or in radians, if we stick with radians, that would be 2 pi like we mentioned up above. Okay? So let's think about this function right here, the cosine function. We're going to plug in angles, and we're going to get out whatever the x coordinate is on the unit circle. So I can start by plugging in an angle of 0. On this one, let's go the other way. I could plug in an angle of negative pi halves, negative pi, negative 3 pi halves, negative 2 pi. Okay, what can I plug into the cosine function? What type of angles? All of them, right? Same thing. Any angle we want, so that's going to be negative infinity to infinity. Okay? Okay, now let's think about the x coordinates that we get out, because the range for the cosine function is the x coordinate on the unit circle. So if I start right here, the x coordinates start out at 1, and then right here the x coordinate is a little bit smaller, and right here the x coordinate is 0. Then what happens? Goes negative, right? What's the biggest negative number we get out? Negative 1. And then the x coordinate gets smaller, okay? I suppose we could say bigger, okay, less negative. Right here it's 0 and then back to 1. So the x coordinates start out at 1, go to 0, go to negative 1, go back to 0, and then go to positive 1. Can't get anything out that's bigger than 1 or less than negative 1, so the range is negative 1 to 1. Those are the type of ratios we get out. Plug in any angle you want, but you're only going to get a ratio out that's between -1 and +1, including that. Okay? What's the period for the cosine function? How often does this cycle repeat? Same thing, 2 pi. Okay? Any questions there? Okay. Takes a little while to adjust your thinking to, talking about domain and range and what we're plugging in and what we're getting out. Okay. Now, I think we did these before. Okay. So if you can, see if you can think your way to the answer without flipping back a page and seeing what we got for these. So this was the sine of pi6. So think about how we did the sine of pi6. Think about what the answer was. I'm going to draw a picture of pi6 right here. Purposely made that pretty small because pi6 is the same as how many degrees? 30 degrees. So this angle right here is 30 degrees, or that represents pi6. And if we're on the unit circle, that would be 1. What's the x-coordinate at pi6? What is it? Okay. This one's going to be the short leg. This one's going to be the long leg because it would be across from the 60-degree angle. So this is going to be radical 3/2. And this one is 1/2. So if I want the sine of pi6, the sine of pi6 is 1/2. Cosine of pi6? Radical 3/2. And does anybody remember what we got for tangent of pi6? It would have been the y-coordinate over the x-coordinate. We had to rationalize the denominator. Correct me if I'm wrong, but wasn't it radical 3/3? Okay, everybody good there? Okay, I'm going to draw a picture for this one right here then. Negative pi6. So if I draw negative pi6, what quadrant would it be in? Quadrant 4. How does it compare to the picture that I just drew here? It's a reflection across the x-axis. So this is a little 30-degree sliver of an angle right there. This is 1. The short leg, which would be across from the 30-degree angle, would be 1/2, and this would be radical 3/2. Now take a good look at that. I mentioned something in the video yesterday that you have to be careful with. These are the right sides. They are the right size. Okay, but there's something wrong up here. What is it? This needs to be negative. Okay? Because if I went to the right, that's a positive x-coordinate, and then I went down, that's a negative y-coordinate. Okay? So I want the sine of negative pi6, that's the y-coordinate, so that's going to be negative 1/2. I want the cosine of negative pi6, that's going to be radical 3/2. And then I want the tangent. The tangent is the y over the x. Take a look at this. The y-coordinate here is almost exactly the same as the y-coordinate here. The x-coordinate is exactly the same. So what am I going to get here? Negative radical 3/3, right? Okay. So let's take a look at this and let's think about this for just a second. What do you notice about the answers? So the answer to sine of pi6 and the answer to sine of negative pi6. Okay, the y changed sign, okay? So this is the same number, but it's the opposite sign. Same for this one right here. Same number, but opposite sign. And what about the cosine? It's exactly the same, okay? And again, you can think about the unit circle and see why that is. Instead of going around in this direction, we went around in this direction. So the triangle looks the same that I drew here as it does here. It's just that we went below the x-axis rather than above the x-axis in order to draw that. So only the y-coordinate changed. The x-coordinate stayed exactly the same. Does that make sense? Okay. So what if I wanted to know this? How does the sine of pi-halves compare to the sine of negative pi-halves? If it's only the y-coordinate that changes, could we come up with a rule that tells us how I can figure out this one, the negative one, in terms of the positive one? going around in a clockwise direction, a negative angle direction, rather than a counterclockwise direction where we have a positive angle. Any ideas? Well, let's draw this. Well, actually, we've got the point right here. There's the point for pi halves. Here's the point for negative pi halves. How do the y-coordinates compare? Okay. Y-coordinate here is 1. Y-coordinate here is negative 1. They're exactly the same, except for when we do a negative 1, we get a negative answer. So this is 1. This is negative 1. So could we come up with something like this? If I had the sign of negative alpha, whoops, make that look like an alpha. How would it be related to the sign of alpha, the original angle, the positive angle? How do we go from 1 to negative 1? Just change the sign, put a negative in front of it. Okay? So this is something called an odd and even function. You'll remember that even means you get exactly the same answer when you plug in a negative x as when you plug in an x. And an odd means you get the exact opposite when you plug in a negative x as when you plug in a positive x. Okay? And that's really what happens right here. Okay? So cosine and its reciprocal secant are even functions. The cosine didn't change at all, so its reciprocal wouldn't change at all. So what that means is if I plug in the cosine of negative t, that would be the same as just figuring out what the cosine of t is. Didn't matter if I was figuring out the cosine of pi 6 or the cosine of negative pi 6, the answer was the same. The x-coordinate was the same, because I was just trading the top half of the circle for the bottom half of the circle, but the x-coordinate would be the same. So the secant of negative t would be the same as the secant of t. Okay, but sine, cosecant, tangent, and cotangent, okay, those all involve a y-coordinate. And because the y-coordinate is different on the top than it is on the bottom, just by a sign, up here it's positive, down there it's negative, okay, those are each odd. We get the exact opposite of what we get when we plug in a positive one. So that means the sine of negative t is negative sine of t. That means the tangent of negative t is negative tangent of t. And the same for cosecant and cotangent. So this would be negative cosecant of t and negative cotangent of t. Now, the ones that you really need to pay attention to that come up quite often are this one, and this one. Okay? Now, let's talk about effectively what do you do with this. Okay? So this is a little formula that helps you figure out what the answer to this problem is in terms of using a positive angle. So basically it means this. If you've got the cosine of a negative angle, you can just get rid of the negative. End of story. It's just the same as the cosine of if you plugged in a positive t instead of plugging in a negative t. Okay? Now this is not what you do, but this is the net effect. Okay? We don't take this and we slide it out front, but that's kind of what ends up happening. Okay? You can't really factor a negative out and pull it out front, but you could think of it that way. So instead of finding the sine of negative t, find the sine of t and put a negative in front of it. Instead of finding the tangent of negative t, find the tangent of t and just slap a negative in front of that. Just change the sign. Okay? So this one says, evaluate the trig function using odd-even identities. So I think I've used this word, but we haven't really talked about it very much. So let's define what this is. An identity is a true equation. Okay? So these that I've highlighted here, in fact, all 6 of those are true equations. And sometimes you can use those identities, those true equations, to make your work just a little bit easier. So if I have the cosine of a negative angle, does it matter whether it's positive or negative? It doesn't. So this would just be the cosine of pi fourths. Now, here's what you need to be good at. At this point, we've only introduced this and talked about these for a day or so. But if I say a week from now, hey, what's the cosine of pi fourths? you better be able to think in your mind and come up with this answer pretty quickly. That's what it would look like. That's 1, that's radical 2 over 2, and that's radical 2 over 2. And I need the x-coordinate right here. So the answer to this is radical 2 over 2. Okay? You need to be able to do that in a matter of seconds. Okay? In fact, you should be able to do it about this quickly. With sine. Sine is an odd function, so I can just find the opposite of what I get when I plug in the positive angle. The sine of this, you should think quickly in your head, this is the diagram I'm looking at. It's in quadrant 1, positive y coordinate. So that would be radical 2 over 2 would be the y coordinate, but I need a negative in front of it. Should be that quicker. Now, just to double check, I wouldn't expect you to do this, but to kind of think this through in your head, that's really the triangle that we're representing here. That's 1, that's radical 2 over 2, and that's negative radical 2 over 2. And there's our y coordinate, okay? This would be negative tangent of pi fourths. And again, for some reason, we tend to memorize the ones in quadrant 1 really easily. Okay, hopefully you've got those down. Y coordinate over the x coordinate, what's the tangent of pi fourths? 1, same thing over same thing. So that would be a 1 with a negative in front of it. And there's our answer. Okay? So those are good things to get used to using, those identities. Okay, we're going to have more of those starting in the next section. Okay, and now we get to use our calculator to find some of these. So go ahead and grab your calculator. And the first thing I want you to do is I want you to check the modes. So when I pull this up here, I've got everything cleared off the home screen, and here's what I want to check. In a trig class, it's really important that if you let your friend borrow your calculator, every time you do a problem, or even if it was yesterday that you used your calculator, before you type something in, check and make sure that it's in the right mode. So we're going to hit the mode button. By default, it chooses radian mode, which is good. Okay? If you want to compute something in degrees, you have to come down here, you have to highlight the degrees, hit enter, and then it would be in degree mode. Now, take a look at this problem right here. What mode do we need our calculator in? We need it in radians, okay? So I'm going to keep that in radians. I'm going to go to the home screen, and we're literally going to type in. Now, you should know what the answer is to this. This is the x-coordinate when the angle, that central angle, is pi thirds or 60 degrees, okay? X-coordinate, that's going to be the short angle, or excuse me, the short side right here. So what's the answer to this going to be? It's going to be 1/2. Okay? Let's make sure our calculator gives us that. So we're going to type in cosine of, and you don't need to do 3.14159. There's a pi button right here. Okay? One above the divide key is the caret key, or that little exponent key. So if I hit second and that button, I get a pi. It's the exact number pi. We don't have to estimate or anything. And then we just divide by 3. We should close the parentheses. And there's our answer of 0.5, exactly what we expect. So if I want to find the sine of 1.2, is that in degrees or radians? And how do you tell? Just because it's a decimal, it could be either. Here's the key. Is there a degree symbol there? Nope, so it's got to be in radians. Okay? So we're going to type in sine of 1.2, close the parentheses, and I get 0.932. Okay, let's take a look at this next one. Anybody know how to compute that? What would the second button do for you? Like that cosine to the -1, does that mean the inverse? Okay, let's not confuse this. It does mean inverse, it doesn't mean reciprocal. Okay? Remember, this is called one of the reciprocal functions because it's the reciprocal of cosine. Instead of being the, let's see, the x over the r, it's the r over the x. Okay, the radius, it's 1 over the x coordinate. So what we do on this is we say, well, that's the same as 1 over the cosine of pi thirds. Now we already figured out the cosine of pi thirds, that's 1/2. So this should be 1 over 1/2. What should our calculator tell us? What's 1 over 1/2? Flip it over, that would be a 2, right? So here's what we do. You literally do 1 divided by, then the cosine of pi thirds. So we do get an answer of 2. Okay, so with that, how would I find the cotangent of 4.4? It's the reciprocal of tangent, right? So I'm going to do 1 divided by the tangent of 4.4. So we end up with 0.322. Okay, now, last thing in this section, the calculators are really cool. They'll help you do a bunch of stuff. Okay, but it's really a good idea to be able to kind of estimate what your answer ought to be, so you know whether or not maybe you typed something in wrong, or maybe you're in the wrong mode or something like that. So we're going to figure out roughly what we expect the answer to be if we're going to do the cosine of 1.4. So figure out whether or not the answer is positive or negative, and whether it's closer to 0 or closer to 1/2 or closer to 1. Because remember, if we're plugging in cosines and sines, we're going to plug in any angle you want, but we're going to get an answer between -1 and +1. So we want to figure out, is it positive or negative first of all? And is it closer to 0, closer to 1, or maybe somewhere in between? Okay? So let's think about this right here. I'm going to blow this up so we've got a little more space here. So think about where 1.4 radians would be. Remember, this is 0, and this is 3.14, or pi radians. 6.28 is all the way around. So does anybody remember what this one is? Pi halves is a decimal. 1.57, and this was 4.71, right? So if I do this problem right here, if I do the cosine of 1.4, first of all, which quadrant would the angle 1.4 be in? It'd be in quadrant 1, and it would probably be about like that. It's a pretty steep angle. And it's the cosine, so we want the x coordinate, right? So the first thing is it positive or negative? It's going to be positive because we're going to the right. Is it a pretty big ratio? Is it a pretty big number, close to 1, or is it closer to 0, or is it somewhere in between? Probably close to 0. So let's type this into the calculator and see what we end up with. So we're going to do the cosine of 1.4. It is positive, and it's just 0.1699. So feel pretty good about that. Sine of 5.3. If that's 6.28 and that's 4.7, I'd say 5.3 is probably somewhere about there. It's the sine. Do I want the y coordinate or the x coordinate? Y coordinate. Y coordinate right here would be negative. Close to 1, close to 0, or close to about 1/2. I'd say somewhere in between. Okay, I'd say probably 0.5. It's not like this. Okay, it's not a really big negative y coordinate. Okay, and it's not like this. It's not a small y coordinate. Probably somewhere in between. Okay, again, we just want to have a good guess here. So we're going to do the sine of 5.3. Turns out it was closer to 1. But we'll go with that. Again, we're just taking a guess there. The important thing is that you make sure you know it's positive or negative. That's really important. Okay? All right. What about the cosine of 3? .14 is right on the line, right? So 3 is going to be like this. We want the which coordinate? X coordinate. The X coordinate over here would be negative. And that should be a pretty big number, really close to -1, right? So let's see what we get here. Cosine of 3, really close. And how about that last one, sine of -1.4? That'd be down here. I want this y coordinate right here. So definitely negative, right? And probably a pretty big number, okay? Close to -1. So let's see what we've got here. Sine of -1.4. And again, make sure, we pointed this out earlier in the year, but make sure you grab the negative rather than the minus. And there we go. Okay. Any questions on anything in the notes? Okay. Yesterday, when some of you responded, and I think 13 out of 17 people responded, so I appreciate that. Some people said the lecture was fine, got everything, understood it, but it would have been nice to ask questions. Totally agree. I'd rather be here teaching you than in a meeting, believe me. Okay. Any questions at all from what we've gone over? Okay. You are not wasting any time by memorizing any of this. I guarantee you're going to use this stuff again. So know those special right triangles. Know the unit circle. Know the radian measure of each one of the angles. Know the coordinates on the unit circle. And hopefully this is pretty easy. If I were to say, hey, could you go through and mark these off in degrees? Say that's 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and go through and do that. If you can do that, then you're in pretty good shape. Please don't overly rely on this. Don't make this so every time you look up a sine or a cosine or need to compute something, you have to look at a piece of paper with this on there. The idea is to get this into your head so you know it like that. You don't have to refer to anything, okay? All right. Sure there are no questions? Okay, good. You've got about 15 minutes to work.